Hi, and welcome everyone to today's webinar organized by the NORA AI Research School Student Council. My name is Francie, and I will be your host today. And together with the NORA Student Council, I'm very happy to have M Esfar E Alam with us today, who will present a talk titled Closing Data Loops, LLM-Powered Databases and Synthetic Data for Circular Economy. Esfar is a Doctoral Research Fellow at the University of Oslo, currently working on the EU-funded C-RISE project. His research explores the intersection of large language models, semantic vector databases, and synthetic data to create intelligent digital infrastructures for a more efficient and sustainable circular economy, particularly around the reuse and remanufacturing of electronic products. Esfar holds a master's degree in computational engineering from the University of Massachusetts, Dartmouth, where he was involved in the NSF-funded research project developing a wearable biosensor system for remote health monitoring in neonates. His thesis focused on cloud-based wireless health monitoring, an area that continues to inform his interest in applied AI for social impact. With over a decade of experience across both academia and industry, Esfar brings a rare blend of practical and theoretical expertise. He has served as a senior lecturer at the Brack University, teaching advanced computer science courses such as artificial intelligence, software engineering, and compiler design, while mentoring numerous research and thesis projects. In industry, he has held roles in major US companies, including United Airlines and EOG Resources, where he developed real-time mobile applications for enterprise and IoT environments. Earlier in his career, he worked at Accenture's telecom division, delivering middleware and high-performance backend services for Telenor and Grameen's phone 5.5 million subscriber base. His research interests today include natural language processing, human psychology through AI, machine learning, knowledge representation, wireless health, digital twins, and AI for sustainability. He has published in top-tier IEEE venues and received several awards for innovation in app development, including winning global startup competitions and national app challenges. And with this, I want to hand over the word to you, Esfar. Please share your screen and have fun.
Thank you. Let me share my screen. Right, let's begin then. Hello, everyone. Thanks for that generous introduction. I'm M Esfar E Alam from University of Oslo. And here we enjoy long winters, strong coffee, and increasingly long conversations about large language model. Today, I'm thrilled to talk about something that sounds like it came straight out of sci-fi novel, Closing Data Loops, LLM-powered database, and synthetic data for the circular economy. Yes, it's a bit of mouthful. A title probably scored high on buzzword bingo, but beneath it lies the serious and timely question: how AI can help us to stop throwing away the very things we are running out. Here's a quick overview of where we are headed. We'll begin with the big picture, the global rise of critical raw materials, why our current take, make, waste model isn't sustainable. Then we will also introduce our project C-RISE and the work we're doing at the University of Oslo to close data loops, especially through Task 4, where my team focuses on digital solutions. From there, we'll dive into how AI and semantic technologies can transform the circular data system and how synthetic data can help fill the critical gaps. I'll also share a personal story how a data storage in my research led me to build a synthetic DPPs and how that journey became a published paper at ICPS 2025. And finally, we'll wrap up with an optimistic note, how AI isn't the enemy of sustainability, but potentially one of its strongest allies. So let me ask you something. How many of us have a phone in our pocket right now, or a laptop open in front of us? Of course, we all do, right? But have you ever stopped and think about what's inside it? What it is made of? How many materials has been used to make this device? Each of these device contains up to 50 materials, not just any metals, but critical raw materials. These are rare, valuable, and geopolitically sensitive elements, and that power your screen, your battery, and also the technologies we desperately need for the green transition, green vehicles, solar panels, wind turbines. Think of CRM as the vitamin of the technology, used in small amounts, but absolutely essential. No lithium, no electric car, no rare earth, no wind turbines, no cobalt, no high performance batteries. And the irony, these essential ingredients of sustainability often come with a dark side: unstable supply chains, environmental degradation. In some cases, conflict zones, many rare earth come from China, lithium from Chile or Australia, cobalt from DR Congo. And these extractions has cost socially, environmentally, and geopolitically. Our dependence on critical raw materials wouldn't be such a risk if they were evenly spread across the globe, but they're not. Take Europe. China supplies nearly 100% of its rare earth elements. If that flow is interrupted due to trade tensions or worse, Europe's tech and green industries will stall overnight. And it's not just China. We are 99% dependent on Turkey for boron, South Africa for platinum. Fragile, these are very fragile source, and it has a single point of failure. We saw this playing out in Ukraine when war broke out. Two Ukrainian companies that produce nearly half of world's neon gas, which is crucial for chip manufacturing, shut down. And just like that, the semiconductor supply chain was in crisis again. And then there is Afghanistan, often called a geological jackpot, with over 1 trillion in rare earths. But instability means those resources remain untapped, or worse, vulnerable to geopolitical bargaining. And the message is clear: the critical raw materials have become geopolitical chess pieces to reduce risk, and we need smarter system, and that includes recycling, reusing, redesigning how we source and manage these materials. We talked about Europe. Let's look at where the global material system stands. And the spoiler alert is it's not looking good. Starting with Europe, despite all the talk about circularity, we're still stuck in a largely linear model. According to latest European Union data, only about 8 to 12% of the materials we consume in Europe have come from recycled sources. That means over 90% that are still virgin materials extracted freshly from nature, used once and then discarded. It's like running a restaurant where 9 out of 10 plates are thrown away after one meal. Now, zooming out to the global level, things even more alarming. The world used over 100 billion tons of materials last year. Of that, only 6.9% were recycled back to use. That means 90 billion tons that were essentially one-way trips are mined, manufactured, reused, and dumped. Or still, this circularity rate has actually been declining in recent years. It's not improving. In short, we are draining the planet at an accelerating rate. And the vast majority of what we extract doesn't stay on the loop. We take, we make, we waste, rinse, and repeat. So, what we're doing about it, what Europe has been thinking. Europe has taken note of this, and if we keep operating this one-way economy, we risk not only climate failure, but also material insecurity. And that is why EU is stepping up with bold targets to double the share of the circular material used by 2030, and to recycle 15% of the strategic raw materials as part of Critical Raw Materials Act. These aren't just green goals, they are economic and geopolitical survival strategies. What exciting is that circularity is no longer just about waste management. It's being treated as core climate strategy. According to UNEP, over 60% of the global greenhouse gas emissions that tied to the way we extract and process the materials. So when European Union says that let's build a circular economy, is actually saying let's slash emissions up to 70% while making our economies more resilient. One of the most promising tools or policy tools on this front is the introduction of digital product passport or DPPs. These are coming fast, and in many sectors, it is mandatory by 2026. The idea is very simple, but it's powerful. Every product from your t-shirt to your battery will come with a digital ID, and that can track what is it is made of, how it was made, the environmental impact, and how it can be repaired and recycled. And this transparency empowers the smarter decisions by the manufacturers, consumers, the recyclers alike. Exactly what we need to close the loop. And this transition isn't just good for the planet, it's good for smart economies. Studies shows that European Union could unlock 1.8 trillion in benefits by 2030 through circular models, not to mention the jobs in repair, refurbishment, and remanufacturing. The bottom line, the circular economy isn't just a feel-good trend, it's climate strategy, industrial policy, and digital transformation all rolled into one. And the data is at the heart of it. So let me talk about the project I'm part of. It's called CRISE, in short, of Circular Economy Resource Information System. It's an Horizon Euro-funded initiative running from 2023 to 2026, involving over 20 partners, like universities, different research institutes, companies, and even global organizations like UNITER. At its core, CRISE aims to extend the life of critical raw materials, especially in sectors like electronics, batteries, solar panels, by improving how information flows across the product lifecycle. Why information? Because one big reason products don't get reused or recycled too simply is this: no one down in the chain knows what inside them. If recycler can see the material in the device, or the repair shop don't know how to open it safely, valuable components end up as a waste. This where the digital product passports come in. Imagine every product carrying a digital twin, listing its materials, components, repair instruction, environmental footprint, and it's updating throughout its life. CRISE is building this infrastructure and piloting it in real-world case studies, from ICT devices to batteries and solar panels. What's the goal of it? The goal is to make sure everyone from the manufacturers, from manufacturers to the recyclers to the consumers has the knowledge to make the circular decision. Because in the end, better data means better choices, and that's how we start truly closing the loop. So this side shows CRISE is turning data into circular in action through 5 key components. The first is we have created a thing called RE criteria. There's a kind of circularity nutrition level for the product. It scores how repairable, reusable, or recyclable a device is. For example, a glued shut smartphone will be scoring low because the design is not modular, while a modular one with screws will score high. Second, we are embedding these RE scores into digital product passport, digital IDs that travel with the product, listing what it is made of, how the repair or the recycling will work, and its environmental impacts. So this creates a traceability across the entire product line uh, throughout its life cycle. Third, we have integrated impact data like carbon footprint or water uses, so users can see and make decisions. So they can see what not just inside, so what is at stake, how it can impact the environment, and make an informed decision. For instance, recycling the device might save X kg of carbon dioxide or to avoid toxic mining. Fourth, we are designing for secure data sharing. Companies are often reluctant to reveal detailed product data. So our system allows selective encrypted sharing with trusted partners like recyclers. And finally, we are building user-facing tools, apps, dashboards, systems that let everyone from consumers to recyclers to policymakers interact with the data. The recycler might see which incoming devices are high value. A consumer might compare products in store with a QR code. We are testing all these in real case studies, from EV batteries to solar panels to IT hardwares. And to improve that with the right data, we can match product with the most circular outcome. In short, C-RISE is building the information infrastructure that turns the circular goal into everyday decisions. Now, what exactly are we doing at University of Oslo within this project? We work on developing what's called Work Package 4, which is essentially the technical heart of the project, the development of the information system itself. I like to say we are building the brain of the C-RISE. What does it involve? First, the architectural design, deciding how the structure or the data connect different components. And we are designing the database that will hold, say, million of entries of product data, material information. But it is not just the traditional database. We're leveraging semantic web technologies, basically building a system where concepts like products, components, materials, etc. are interlinked. That means if one data set calls something PCB and other calls it printed circuit board, we ensure the system knows what's they're the same and they can link it. This is crucial because the data coming from different players in different formats. So here integration is the key. We are also handling the backend development, the server logic, and takes the data and process it, applies it to the RE criteria solutions. And the front end, to some extent, to making the web interface or apps that different user will interact to search data and retrieve info. A huge focus of us is making the system smart. It is one thing to have a lot of data stored. It's another to quickly find out what you need to or glean insights. This is where AI comes in within our work. We have been researching how to implement the semantic search and natural language querying. In fact, a few of us, including me, working on different intelligent semantic search and LLMs for integrating the material data. The data is down the line. A user might not need to know how to do technical database queries. They could just ask the system, hey, which computer models have the highest recycled plastic content and are fully recyclable? And the system AI would understand and then summarize and fetch the answer by looking through all the linked data. We're essentially prototyping this capability. So UIO's role is both building and innovating. We are ensuring that C-RISE platform isn't just a static repository, but a living smart system that can help decision making. It should be able to crunch the data to answer complex questions, help find patterns, and generally be user friendly. It is an exciting role because we get to play with different advanced tech like knowledge graph, AI assistants, LLMs in context to very tangible real world problem, like keeping materials in use. And collaborating with the rest of the consortium, we make sure our tech aligns with the need of the industry partners. The recyclers, etc. It is the classic interaction of computers and the sustainability, a fun place to be. So are you still unclear? We'll talk about how we can empower circularity from our end on the next slides. So here's the things start get exciting. The AI and the circular economy may not sound that it's an unlikely duo. One digital and tangible, the other is material and planetary. But together, they pack a serious synergy. Across the entire product life cycle, AI can help us to do more with less. In the design phase, generative AI creates parts that are lighter, modular, and easier to recycle. Like Airbus did this with a partition that's 45% lighter. That's not just less material used, it is less fuel burn, fewer emissions. During use and reuse, AI enables predictive maintenance, smart inventory systems, elevators that diagnoses its own issues, bike sharing platforms that adjust pricing dynamically to avoid ideal fleets. At the end of the life, AI helps sort, disassemble, and route products and materials with surgical precision. IKEA now uses AI to decide whether to resell, donate, or recycle or return. And it keeps 85% of the used furniture in circulation. And let's not forget about economic angle. Just in food sector, only AI applied with circular practice could unlock 127 billion per year by 2030. That's one industry. Imagine when we scale this across electronics, fashion, construction. So yes, AI isn't just a smarter assistant, it's a strategic partner in redesigning and sustainable economy. The circular economy isn't just about materials, it's also about data. Right now, circularity suffers from serious data silos. Product data is over here, recycling rates are over there, regulations in other tab. This fragmentation is a killer for insight. Intersemantic technologies, knowledge graph ontologies that help us to connect these dots. They tell the system that copper is a metal used in wire inside a PCB in a smartphone. This structure is crucial for understanding the relationship and building an intelligent system. Now, a layer of language, LLM or large language models on the top, and magic happens. You don't need to write the complex queries. Just ask which smartphone is released after 2024 contain no cobalt. So if I ask you to build a query for that, you will have to think a lot or make a system that process a lot of things. But with LLM, it's just easy. And the system understand that's not just smart, that's accessible AI, turning complex databases into tools that anyone can use. This slide sums up why LLM and semantic system together are a game changer for circularity. They support better decision, pulling insight from across the environmental market, material data. They democratize the access so that even the non-tech users like sustainability manager or factory teams can extract insights easily. They reduce hallucination risk because LLM draws from structured graph of verified facts, and they learn over time, becoming more useful as more queries, users, and database comes in. Think of it as building a Google map for materials, but instead of routes, it tells how you keep things in the loop. So now I will share a small story because I guess it's 20 minutes, so all of us are tired. Back in 2005, some mischievous MIT students built a tool called Cygen, which generated completely fake academic papers, just nonsense with jargons, but grammatically correct. And somehow, one of them accepted at a major conference. This was a wake-up call for the academic world. Synthetic content can look real, even when it is utter gibberish. Now, fast forward today, I'm working on synthetic data, but not the kind meant to be deceived. Quite the opposite. It is useful, structured synthetic data meant to fill the gaps when real data is missing or locked in. So yes, we have come a long way from prank papers, but the lesson holds. We need rigorous evaluation to make sure what looks good on paper and is actually good in practice. So synthetic data sounds like something out of sci-fi movie, but it's already empowering the real world. It's data generated by algorithms to mimic the real data, whether there's a DPP, a financial transaction, or a kangaroo jumping in front of self-driving car. True story, by the way. Why use it? Is fast and cheap, is privacy safe, and it fills the gaps where real data is rare or inexistent, like digital product passport. In fact, in 20% of modern AI training data today is already synthetic, and by 2028, Gartner predicts that number will hit 80%. So synthetic data is becoming the imagination engine for AI, but at this is a key for it must be validated and well structured as well and human aligned. Otherwise, we are back to a fake paper problem. Here's a snapshot of how synthetic data is exploding. 20% of AI training data today is synthetic, as I said, and by 2030, it may outnumber the real data in AI systems. The market is booming, expected to hit 3.5 billion by 2026, and 73% of ML engineers say mixing synthetic with real data improves the total performance. Done right, it helps us address bias, scale faster, simulate the what ifs if we could not afford to wait for. In short, synthetic data is no longer a plan B. It is a strategic tool for innovation in sustainability, AI, and beyond. This was a core challenge I set out to tackle in my research. We want digital product passport, but we do not have the data to build or test the system properly. The data doesn't exist and is often fragmented, proprietary, or inconsistent, a major barrier for the innovation in the circular economy. So I turned to a different approach. If we don't have enough real data, why not generate the synthetic data? So that is why I published a paper regarding synthetic data generation along with how to measure the quality of the data. We'll discuss the paper in detail next. So now you're talking about the elephant in the room, the data, right? So rather the lack of it. The digital product passport are one of the most promising tools in EU circularity arsenal, but we face a critical bottleneck. We simply don't have enough real-world DPP data. Most of it is proprietary, fragmented, or doesn't just exist yet. So it's like trying to build a Tesla with a screwdriver and a dream. So the data gap stalls the innovation, and we cannot retrain the models. We cannot test the systems. We cannot move fast if we are always waiting on someone else's data. So the question is, how do we move forward when the road is blocked? As told, I took a creative route and I turned the synthetic data. I used a few-shot learning approach. That means instead of needing thousands of DPP examples, we give the model uh, just uh, just a few well-structured samples and let it fill the rest. Think of it as showing your AI a recipe and asking it to invent the whole menu. We tested this across several LLMs like GPT-2, Llama 3.2, Gemma 2 billion, and my personal favorite, GPT-4 mini in this case. This model weren't trained specifically for DPPs, but with smart prompting, they learned the format and tone surprisingly well. Each model had its own personality, shall we say. GPT-4 Mini delivered consistently accurate, coherent, and well-structured DPPs. And Llama 3.2, Gemma 2 billion did okay, but occasionally added odd extras like model instruction or chatty intros. And it's like asking for data sheet to getting a motivational speech. What about GPT-2? Let's just say it tried its best, but it did not work out. But it is there for the comparison reasons. Importantly, all models used the same prompt and few short examples, so we could compare the apples with apples actually. So here where things got fun. While smaller models like Llama and Gemma sometimes scored well in automated matrices, the output did not always make sense to the human, and they look good until you read them. GPT-4 Mini, on the other hand, wasn't fast and memory efficient. It produced text that humans constantly preferred. The key lesson is don't trust the metrics alone. Trust people who have read the inputs. If you can see this table here, you can see this was our reference DPP and a small excerpt of it. And this is our GPT-4 Mini output, which even looks better than our reference DPP. For Llama, it looks okay, but there's noise like you are an expert in DPP, which was part of our prompt. So it is included into the output, which is not expected. And for GPT-2, it just make worse, but it doesn't make any sense. So this is how it worked out. But when we came to matrix point, GPT-4 Mini score almost at par with Llama and Gemma. So to evaluate the generated DPPs, we used two popular NLP matrices like BlueRT and Comet. So BlueRT checks how semantically similar a generated text is to a reference, and Comet evaluates the fluency and the adequacy of it. In other words, does it sound good or does it say the right thing? So here's the catch. These metrics weren't designed for structured, open-ended text like DPPs. They're actually built for translation. Sometimes they favor the sameness over the quality and rewarding the models that mimic the reference without considering the readability or the user relevance. But it still shows indication that which model is working good or working bad for our DPP generations. So how we can make it work better or give best result in our cases. So we introduced our own metric, which is called HCA. So meet HCA, it's called hybrid composite analysis, where we combine BlueRT and Comet with human feedback from circular economy experts. Why did it do it? Because while machines are good at spotting patterns, only human can say this actually makes sense. And HCA give us a single score that reflects the real world usefulness, not just a surface of the similarity. So it's like adding test to the recipe ratings. So not just checking for the ingredient matches. So here's what happened when we brought HCA into the picture. Our automated metrics alone, Llama and Gemma, look competitive, even beating GPT-4 Mini in many cases. But when we added human judgment through HCA, GPT-4 Mini was the clear winner. The gap was real. So the moral of the story, if we had trusted the bots alone, we would have picked the wrong model. And that's exactly why HCA matters. It makes sure our evolution aligns with the human needs and not just machine logic. So this is the weight we have assigned to BlueRT and Comet and human feedback. As you could see, human has the highest weight, but it can be adaptable. It is debatable that oh, what if we can change it, which is a part of future exploration, I would say. So what's next? This future learning framework isn't just for DPPs. It could work anywhere we have a structured text or no real data, like simulating ECG reports, sustainability scores, training AI with eight case scenarios. We are exploring better prompt engineering, adapted HCA scoring, and ways to generate the machine readable data formats like JSON or asset administration cells. So it is not just readable, but usable by other systems as well. Because in the end, the circularity isn't just about materials. It is about also the information flow too. So let me close with a thought that often surprise people. AI is not the enemy of the environment. Yes, AI can be energy intensive. Yes, it is a part of a tech ecosystem with its own sustainability challenges. But used wisely, AI can do something extraordinary. It can substitute data for distraction. It helps us use fewer raw materials, extend product life, design out the waste altogether. It doesn't just automate, it regenerates. And that's exactly what the circular economy needs. My work from few short synthetic DPPs to human aligned evaluation via HCA is one small step forward that a regenerative future can hold. A future where semantic database and language model aren't just tools, but partners in sustainable transformation. We have shown how synthetic data can fill real gaps and how machine can support human goals. How intelligence, if guided well, can serve not just speed, but as a stewardship. I'm deeply grateful to Professor Amit Tahirpurdi, whose mentorship helped bring this version to life, and to the CD Rise Consortium, whose funding and collaboration made this work possible for me. And to all of you, thank you for joining me on this journey, and let's keep closing the loops, opening mind, and building a smarter, cleaner, and more circular future. These are the reference that I have used. I think for the next part, I will open to any questions and answers if you have any.
Amazing. Thanks so much for your really great and inspiring talk, Esfar. So if anyone in the audience has any questions, I think you can either post them in the chat or just speak up. I'm assuming that works. If there's no questions
I think
from
we
the
presented
audience,
so well that nobody has any question.
yeah, exactly. You answered all our questions on the way already. I think I have a small question. Maybe that is a start for the questioning round. So you said you're using LLMs to create digital product passports, right? And to fill the gaps that you're having there.
Right.
But so I don't fully understand. So you said it, I mean, we all know that AI is hallucinating a lot. So you're creating these digital passports for products. How do you know that, for example, the CO2 footprint, which seems very hard for me to guess by LLM, how do you ensure that this is actually somewhat correct? Or like how is it connected to the actual data in the knowledge graph that you talked about?
So I collected some organic DPPs from different sources from our partners, and then use that to generate the data. So, but I mean, the LLM is already well trained. We cannot be better than OpenAI to train the data, right? I don't have that much money. So what we
Fair.
can do, we have provided a small amount of data because it is already well trained. It can learn with that small amount of data, which is called few shot learning. Because to make a child learn that this is a lion, it's enough to show one lion, right? We don't have to show him all the lions in the world. So the LLM is already well trained. We just give it a small amount of informations of organic data and ask it to mimic it. And as you can see, most of them worked well except GPT-2. And they have generated, I mean, it's a creative task. So it created new data randomly from its own creative values, but it also had a structure. It is not like an open-ended story or novel, so it could work. So we mimic the real data, but it's not the real data, of course.
Okay, thanks. And we got a question from the audience. I'll just read it out loud and you can answer.
Sure.
So the question is, can you say a few words about the acceptance of the idea of the digital twin in the industry?
Um, can you ask the question again? The acceptance
Yeah.
of digital.
So I think you should explain, or what do you think about how well accepted is the idea of using these digital twins in the industry setting?
Is well accepted now. I mean, in the last conference that I have attended, is it was all about digital twins because uh, in future we'll have a lot of IoT devices as we have expected. So all these IoT devices and the main devices that can connect to these IoT devices will make a digital twin of every product we have been using, and the changes in real time will reflect on the digital twins so that we can always keep monitoring. So in industrial scale, it is very acceptable and highly invested. In personal levels as well, like in cars, it will be it's already there, and it will be more and more visible in recent futures, I guess. So the idea of digital twin in a real time world will be very much acceptable. That's what I believe. But I'm no future teller, so I cannot predict the future. But I think it will be a big thing.
Cool. Thanks for your answer. I can't see any other questions right now, but maybe let's give the audience another minute. But otherwise, I can already say I think it was a really great talk, and we're really happy to have you as our speaker today. And to the audience, we will have this format again in a few months' time, probably. It will be announced through the usual channels of NORA. Yeah, I
All right.
don't see any new questions.
I
So,
guess
oh,
it's
there's a new question.
I,
There's a question if you could get a copy of the slides, if you're willing to share those or parts of them.
I can share with you an email and then you can disperse.
Yeah, so if you share with us, then I can share with the attendees afterwards, if that's fine with you.
Yeah, that's fine.
Amazing. Cool.
All right. Thank you. Have a good day, guys. Bye.
Thank you so much. Have a good rest of the day, everyone.